Following student, tectonic plates, the Earth's moving motion, the jagged spears, tectonic plates in movement, the crust and down to the magma spears. Now, how these plates slide over hot liquid plates, melting deformational boundaries, is a way of motion for all faults into how the crust cool core heading directional freeze of the energy static equilibrium cracked or break at an angling weight, distributing the stress, strain, and impaction, channeling deeper and deeper into a bending or straight again around a hot spot surface motion compared to same spots of the litmus spheres bend in difference. A list of plates and directional motions are the Juan du Funkel plate in between the North America heading southwest and the Pacific plate moving northwest at about 2.3 centimeters. The Caucasus is moving 67 millimeters a year. The Nasdaq plate absolute motion is calculated at about 3.7 centimeters a year, and an east motion at about 88 degrees, one of the fastest tectonic plates there are. The South America moving plate is moving westward away from the mid-Atlantic ridge. The eastward parts moving at a more dense than the Nazca plate is subducting under the edge at a rate of 77 millimeters, 3.03 inches a year per year. The Scottish plate is about 25 millimeters a year. South America plate and the Antarctica plate. The Africa plate is about 2.15 centimeters a year, 0.88 inches moving in the northeast direction. The Eurasia plate moving south at 7.14 millimeters a year, and the Arabian plates moving 20 millimeters a year. It's moving north. The Indian plates moving 15 centimeters a year, about 36 millimeters a year, and going northeast. The Australia's plate part is moving northward at a rate of about 5.6 centimeters, 2.2 inches per year, while the western part's moving 3.7 centimeters. At the Pacific's place, about 7 centimeters a year. At the northwest, moving northwest, that's about 11 of the plates, kind of the main ones. But they say there's 17 plates, and they're still subdivided from divergence and convergence plates. But these plates, as a measure of convergence and divergence now on a strike slip fault, is the untangled fault surface plane is usually near vertical footwalls that move laterally either left or right, while very little to the vertical motion is the fault in the left motion right is called a directional. A dip slip fault occurs either as a reverse fault or a normal fault. A normal fault occurs when the crust is extended to the gravity slide, and these type of combinations is significance of strike slip and the dip slip, both to oblique, pretty much the same, because they kind of move in two ways, but there's more ways than that. How the rock combines. There's about 75 different igneous type of rocks, 36 sediments and 27 metaphoric rocks, 35 specific varieties, and 173 fragmentational bonds and finer grains in a vector matrix of similar compositional rocks and mineral elements, ores with auras. Now imagine what's holding up the earth. Well, I imagine Earth's mineral rock and different element ores is channeling a new stage of agement in the astronomical count in depth travel and transfer. Now, how we study the core. First, we need to understand how different rocks, ores are in the air to each other, aurora. Next, we need to understand how the earth world sphere spreads and subducts. It's more crust created than there is crust being pulled back into the magma. Earth waves of motions from the crust down to reversible ionical friction that rattles in the core dimensional depth, the volume of the potential outburst, a color wheel property, and all atoms recombined in the following directional of the space, directional flow of the invisible glow. Tectonic plates from the following student.